Hello everyone. In today's video, I'm going to do something a little bit different from what I usually do. Rather than attempting to solve a math problem that I see for the first time, I'm going to be attempting to solve the entire AMC 10 from 2022. If you don't know what the AMC 10 is, it stands for American Mathematics Contest. It's typically written by students who are about 15 years old. The format is 25 multiple choice questions that get more and more difficult the farther you go into the exam, and you have 75 minutes to complete the test. In terms of how I'm going to do this, I'm not going to time myself. I'm actually just going to attempt to solve each question from beginning to end. The reason I'm not going to time myself is because I will be giving a little bit of commentary as I go through, especially on each question when I first see it. And then I'm going to work through on my own and maybe give a little bit of commentary towards the end after I've solved the question. I should say, actually, I've already recorded my attempts to do all of this. And let me tell you that this test was actually quite a bit more difficult than I expected. It starts off very straightforward, but there were a substantial number of questions that I'm either not confident in my solution or didn't end up getting a solution, which is kind of nice to see, right? Now that I've finished recording my attempt at each question, what I'm going to do is go back and look at my solutions and give sort of a post-mortem commentary on each of the questions. In particular, I'm going to look at the solutions of the problems and let you know which ones I ended up getting correct or incorrect as I go through. For the ones where I don't actually propose a final answer because I couldn't solve the question, I'm going to skip those. And then I might give some kind of brief overall summary towards the end about what my thoughts were on the entire process. So keep watching. If you're interested in this type of contest stuff, let me know. I'd like to do some more of these in the future. Enjoy. See you at the end of the video. Problem 1. What is the value of 3 plus 1 divided by 3 plus 1 divided by 3 plus 1 over 3? Okay, so this is going to be a standard simplification of this continued fraction. It's not an infinitely continued fraction. It does terminate after this specific number of terms. So my first approach here, my first thought is to just simplify this from the bottom up. Okay, so this is the answer that I get, 109 divided by 33, and that is one of the available selections in the multiple choice. So I'm pretty confident with that. Let's take a look at the next one. Mike cycled 15 laps in 57 minutes. Assume he cycled at a constant speed throughout. Approximately how many laps did he complete in the first 27 minutes? Okay, so my first thought is just to write down explicitly the relationship between speed, distance, and time. We're given a distance in the form of laps and a time, so we can compute his speed. And then we're given a time and asked to compute a distance in terms of laps. So this should be a straight conversion. All right, so to the nearest integer, the number of laps that he completed is 7, and 7 is one of the available options in the multiple choice. And in fact, neither 6 nor 8, the next two closest integers, are given as options. So I'm pretty confident in that answer. Let's check out the next problem. The sum of three numbers is 96. The first number is 6 times the third number, and the third number is 40 less than the second number. What is the absolute value of the difference between the first and second numbers? So I think let's just set up a system of equations that all three of these numbers have to satisfy. I'll call the three numbers x, y, and z. And we'll call this the first, second, and third number in that order. So we're told that x plus y plus z is 96. We're also told that x is 6z. And we're told that z is y minus 40. So this should be enough to solve for all three numbers. And then we want the difference between the first and second numbers. So I think just solving for x, y, and z altogether is probably the easiest and most straightforward way to do this. So I've got that the difference between the first and second number is 5, and that's one of the available answers, so pretty confident with that. Let's take a look at the next one. In some countries, automobile fuel efficiency is measured in liters per 100 kilometer, while other countries use miles per gallon. Suppose that 1 kilometer equals m miles and 1 gallon equals L liters. Which of the following gives the fuel efficiency in liters per 100 kilometers for a car that gets X miles per gallon? Okay, so just a lot of unit conversion stuff. My first thought, excuse me, my first thought here is an easy way to do things that have to do with unit conversions is literally to just write down equalities that hold for the units. So for example, we're given that 1 kilometer is equal to m miles. Okay, so I'm going to use capital M for the unit of miles, and I'm going to use a capital K for the unit of kilometers. So I can now think about K, lowercase m, and capital M as just being variables, and this is a relation that holds between them. And we know we're given that 1 gallon is equal to L liters. So again, I can think of G, lowercase l, and capital L as just being variables that satisfy this equation. So we need the fuel efficiency in liters per 100 kilometers for a car that gets X miles per gallon. So let's let E be the efficiency of our car. We're told that this is equal to X miles per gallon. And we want to write this in terms of liters per 100 kilometer. Okay, this took far longer than it should have. I'd be pretty disappointed in myself if I were actually writing this contest. I just kept making a silly algebra mistake in replacing this. I'm used to thinking of writing miles in terms of how many kilometers there are, not the other way around, so I kept substituting the wrong thing. But anyway, the efficiency measured in the appropriate units with all these conversions is ml divided by 100x, which is one of the options given in the multiple choice. So I'm pretty confident with this now, especially after having checked my rough work several times. Problem 4 is the first one that I got incorrect, and this was quite surprising. In fact, of all of the incorrect solutions that I submitted, this is probably the most surprising for 2 reasons. The first is that it occurred quite early in the test. This is a really straightforward problem. And the second is that I made a few silly mistakes while I was solving the question, and I knew I made those mistakes. And so I did sort of a sanity check and redid the computations. And when I redid the computations, I got the correct answer. And when I compared that to the answer I submitted, for some reason, I thought they were the same expression, but they're clearly not. If I look at my work, when I went through and checked my solution by just redoing it, I got the right answer, but it's not the same as the thing I submitted. So I don't really know what went wrong here. Very surprising and kind of a little bit of a disappointment at the end of the day that my first incorrect answer came so early in the test. Let's take a look at the next one. Square ABCD has side length 1. Points P, Q, R, and S each lie on a side of ABCD such that APQCRS is an equilateral convex hexagon with side length S. What is S? Oh my goodness. Okay, so let's draw a picture immediately. So we're given another 4 points, P, Q, R, and S. Each lie on a side. Doesn't say they lie on different sides, but A, P, Q, C, R, S is an equilateral convex hexagon. Okay, so I believe the other points we need are probably something like this. 1, 2, 3, 4, 5, 6. So there's our hexagon. And if I label the points P, Q, R, and S like this, we need to figure out basically where this point P lies such that all of these 6 side lengths are the same. It's an equilateral convex hexagon, but it's not a standard hexagon because this is 90 degrees while this is 135, but I think that's fine. Okay. So what I'm going to do here, I think I will let this distance here be x, and then that means this distance here also has to be x, and this of course has to be x. And if I think about sliding this point left and right, then I need, that's also going to cause, if I slide P to the left, that's kind of similar to sliding Q downwards. And I need to find the value of x such that the distance between P and Q is also equal to x. Okay, so solving this polynomial gives me that x, which is in fact s from the question, is 2 minus root 2, and that is one of the options in the multiple choice, so pretty confident with that. Let's move on to the next one. Which expression is equal to the absolute value of a minus 2 minus the square root of a minus 1 squared? So my instinct here is to just simplify this somehow. Of course, we'll have to be a little bit careful with the sign of a. But I don't see why we can't. Yeah, the reason we'll have to be careful about this, for one thing, is canceling the square root with the square. The sign of things underneath will matter. And also, just in general, we have an absolute value of something, so we'll need to be careful. Oh, sorry, I missed part of the question. A is negative. So let's just go ahead and simplify some stuff. In fact, what I'm going to do is I'll make a substitution first that a is equal to negative x, so that we can just work with a positive variable x everywhere. So just keeping track of things that we know are going to be positive, we ended up with this answer, and this is one of the options in the multiple choice, so pretty confident with that solution. Let's take a look at the next one. The least common multiple of a positive integer n and 18 is 180, and the greatest common divisor of n and 45 is 15. What is the sum of the digits of n? Okay. So, I mean, I'm kind of tempted to almost brute force what the potential values of n could be. Okay, well, n will not be 10 because 15 is not a divisor of 10. I think 30 might work. Okay, so if n is equal to 30, greatest common divisor between 45 and 30 is 15. And the least common multiple of 18 and 30, well, 18 times 10 is 180. 30 times 6 is 180. And we're not going to get a lower multiple of a lower common multiple, right? Because 180, before I write it there, 180 is 9 times 2 times 2 times 5. 2 squared times 3 squared times 5. Yeah, so the fact that there's a single 5 here means we're not going to get another lowest common denominator. And so the sum of the digits is 3. And that's one of the answers in the multiple choice, so pretty confident with that. Problem 7 is the next one that I got incorrect. And this happened because of a silly oversight. I did not check that the number 30 actually satisfies the conditions that are given. The number you're looking for here for n is 60, so the answer is 6. Let's check out the next one. A data set consists of 6 not distinct positive integers, 1, 7, 5, 2, 5, and x. The average of the 6 numbers equals a value in the data set. What is the sum of all positive values of x? Okay, so I think we just set up the equations that represent the information given to us and figured out. Okay, so I don't like the wording of the question because so the average of the 6 numbers equals a value in the data set. So there could be multiple values of x that work here. It asks for the sum of all positive values of x. I think it should say the sum of all possible positive values of x. But anyway, let's just go ahead and figure this out. So I get an answer here of 32, which is one of the possible answers given in the multiple choice. So again, pretty confident with that. Problem 8 is another one where a silly oversight had me miss the solution. I missed one of the 3 possible values of x because for some reason I didn't allow my indexing integer to start at 0. I'm not really sure why I slipped up there, but got the wrong answer on problem 8. Let's take a look at the next one. A rectangle is partitioned into 5 regions as shown. Each region is to be painted a solid color, red, orange, yellow, blue, or green, so that regions that touch are painted different colors and colors can be used more than once. How many different colorings are possible? Ooh. So sort of a combinatorial problem. And I think we're just going to have to work out, based on this picture, I think I'll just sort of start to eliminate possibilities. Like I'll kind of multiply through how many choices we have at each point in time. Okay, so we have 5 different colors. So I can put 5 possible things here. Then I could put 4 possible things there, 3 possible things there. But then it's not going to be 2 here anymore. It's again going to be 3, because whatever color we put there can also be put there. And similarly, in the bottom right, there should be 3 colors we can put here. And now if I multiply these all together, is that it? I think that's it. I don't think we have to worry about more permutations or anything like that. It's kind of it's all there. And 540 is one of the multiple choice answers given, so pretty confident with that. Let's look at the next one. Daniel finds a rectangular index card and measures its diagonal to be 8 centimeters. Daniel then cuts out equal squares of side 1 centimeter at 2 opposite corners. The index card and Daniel then cuts out equal squares of side 1 centimeter at 2 opposite corners of the index card and measures the distance between the 2 closest vertices of these squares to be 4√2 centimeters, as shown below. What is the area of the original index card? So the diagram we're given looks something like this. So we're told that this diagonal D is equal to 8, and this sort of mini diagonal, let's call it D2, is equal to 4√2, and these smaller cutouts there are equal to 1. So I think we just write out the relationship between these variables somehow, work out the geometry of what's going on, write out some Pythagorean things that define what D1 and D2 are. Maybe I introduce some variables to be the length and width of everything. Okay, so I end up with the length times width is 18, which of course is the area. 18 is one of the multiple choice answers given, so I'm pretty confident in that. I guess it was a little bit interesting that we, at least I don't see how to do it, where we couldn't solve for L and W individually. I only was able to work out their product. I'm not going to think more about if there's ways that we can figure out L and W separately. I'm happy enough with this at the moment. Ted mistakenly wrote 2 to the m times the square root of 1 over 4096 as 2 times the m root of 1 over 4096. What is the sum of all real numbers m for which these two expressions have the same value? Okay, my instinct here is to just set these two things equal, work out some algebra, and see if we can solve for m. So let's just go ahead and do that, and hopefully there's no problems. Okay, so it doesn't look like there were any problems with that approach, just solving for m algebraically. We get that m is equal to 3 or 4. And 3 plus 4 is equal to 7. That's one of the answers in the multiple choice, so pretty confident with that. Maybe direct inspection would have been a little bit quicker on this one, but we got there. All right, let's take a look at the next one. On Halloween 31st, children walked into the principal's office asking for candy. They can be classified into 3 types. Some always lie, some always tell the truth, and some alternatively lie and tell the truth. The alternators arbitrarily choose their first response, either a lie or the truth, but each subsequent statement has the opposite truth value from its predecessor. The principal asked everyone the same 3 questions in this order. Asked everyone the same 3 questions in this order. Are you a truth teller? The principal gave a piece of candy to each of the 22 children who answered yes. Are you an alternator? The principal gave a piece of candy to each of the 15 children who answered yes. Are you a liar? The principal gave a piece of candy to each of the 9 children who answered yes. How many pieces of candy in all did the principal give to the children who always tell the truth? Okay, so, oh my God. Oh, it's also not on Halloween 31st. It's 31 children. Okay, so there's 31 children that are being tested with these questions. I think maybe like a combination of brute force and trial and error here would normally be my first instinct, but I think maybe that'll kind of take a long time. I think I might just set up some variables for the number of children that are of each type and see if I can translate all the statements here into equations and solve for the number of children of each type. I need one clarification though. The alternators arbitrarily choose their first response, but I don't believe they each have to be the same. Okay, well, anyway. Okay, so working through all this algebra, I find that there are 7 truth tellers, and they only receive candy on the first question. So the truth tellers are given 7 pieces of candy in total, and 7 is one of the multiple choice options. So I'm pretty confident with this, but that was actually kind of a tricky one. Kind of cool question. Let's take a look at the next one. Let triangle ABC be a scalene triangle. Point P lies on BC so that AP bisects BAC. The line through B perpendicular to AP intersects the line through A parallel to BC at point D. Suppose BP equals 2 and PC equals 3. What is AD? Okay, so we're given a whole bunch of information about triangles, lines, and angles. I'm just going to draw a picture and see if I can solve for what we're being asked to solve for. This has been a pretty frustrating one. There's got to be some identities about triangles and bisecting angles and right angle intercepts and so on that would allow you to solve this, but I haven't done this kind of geometry in a long time. I think for now I'm going to pass on this. I'm going to come back to this question later at the end and see if I can just figure it out, but I feel like I'm not running in circles here with labeling all these angles and so on, but I just feel like time would be better spent going on to the next question. Yeah, but I'll come back to problem 13 after I go through the rest of them. Let's take a look at number 14. How many ways are there to split the integers 1 through 14 into 7 pairs such that in each pair the greater number is at least 2 times the lesser number? so the numbers 1 through 14, yeah, if we're splitting this into pairs, then there are 7 pairs of integers. And the greater number is at least 2 times the lesser number. Won't this be, so my thought is that this is not, my instinct here was that there would be very few arrangements of these numbers where this works. But when I look at the multiple choice answers, all of them are greater than 100. So let me think for a second here. I'm not really seeing how to break this down into something simple to compute, right? Like I'm pretty sure that I think that 7 and 14 have to be paired together. But then of the remaining small integers, 13 can be paired with anything, but if 13 is not paired with 6, then 12 has to be paired with 6. And so it keeps breaking down into all these subcases depending on what the higher pairs are. I'm going to come back to this one again as well, because I don't see I don't see a quick combinatorial formula that sort of makes this work. Maybe I'm not thinking about it properly, but I'm going to come back to that. Let's look at number 15. Quadrilateral ABCD with side lengths 7, 24, 20, and 15 is inscribed in a circle. The area interior to the circle but exterior to the quadrilateral can be written in the form a pi minus b over c, where a, b, and c are positive integers, such that a and c have no common prime factor. What is a plus b plus c? I can tell you already this is going to be difficult for me. Again, this style of geometry problem is not something that I have really seen a lot. So we're given quadrilateral A. Let's try and draw this at least somewhat to scale given the lengths we have here. A, B, C, D. So the lengths here are 7, 24, 20, and 15. I mean, I'm tempted to divide this quadrilateral into triangles, but I mean, there's tons of formulas for the relationship between, side lengths of shapes inscribed in circles and so on, that I just don't know what those formulas are. So this one, kind of like the previous geometry problem, I think would take me a long time to figure out. So I'm tempted again to just skip this one for now. I don't immediately see a way of figuring this out that won't take a really long time. Come back to it. Problem 16. The roots of the polynomial 10x cubed minus 39x squared plus 29x minus 6 are the height, length, and width of a rectangular box. So right triangular prism. A new rectangular box is formed by lengthening each edge of the original box by 2 units. What is the volume of the new box? Okay, this one I think I have a pretty good idea of how to figure this out. So the roots of this polynomial, I'll write out the original polynomial here, minus 39x squared plus 29x minus 6. So if I write this as, so the roots of this polynomial are the height, length, and width. So if I factor the polynomial like this, let's put a 10 out in front, then the roots, if the roots are h, l, and w, then the polynomial can be factored like that. And then we're told that we lengthen each of these lengths by 2 units. So, well, let's solve for, I guess we're going to need some relationships between h, l, w and the coefficients of the polynomial on the left. And then I just want to write out, I might just write out a new polynomial where we increase these all by 2 and multiply them all out. Okay, let's do that. All right, for this one I get 30, which is one of the multiple choice answers. I made some really simple mistakes in expanding products of polynomial form things that maybe have to do this again. But anyways, 30, I'm pretty confident in this answer. Let's take a look at the next one.